Well, hello again, it's Cliff here from Down Under. In this video series, I want to go through making the Hallmark ITTP Bodies as an example of medium scale batch production. So it's going to be parts production from small CNC machines like the Tormachs. So I'll start right at the beginning with the raw material and setting it up in the Tormach lathe and machining one end, spinning it around, machining the other end, setting up the tools and discussing all the little tips and tricks along the way. Then the next stage will be setting it up in a little 3-axis mill, machining the top portion or the end portion of the body, setting it up the next. If you like, it's a video book, but a hands-on book. There could be chapters or episodes. The next chapter might be doing the 4th axis machining and so on. So I'll go right from the beginning. Hopefully I'll get as far as the final part. And it'll be a great opportunity to demonstrate different setups, different machining techniques, tips and tricks along the way. And I'll also mention other videos that are relevant so that you can go through and find those in the Thread Express YouTube playlists. Well, before we get down to the nitty-gritty of each chapter or episode, I'll put in a quick montage just giving you an overview of what these videos is about so you can put it in context and see where it's all going and where you have been before if you've watched other episodes, just to bring it all together at the beginning of each video. Cheers. So now I'm going to machine the other end of the bodies. So it's about 2 strokes of a hacksaw to zip off that little bit left that's not quite parted through. Yeah, if you don't part your job right off when you're doing back-to-back machining, just leave a few thou on and it's just like that, and you've separated them into 2 parts and just saved yourself a lot of grief for the sake of a few seconds work. And I'll set that up in the lathe now and machine the length of the body, the outside radius, the finished bore of the inside at that end, and put that chamfer on there and machine the groove. So that'll be 3 different tools. Set those up in the turret. So I'm just setting up the tools in the turret now, and why don't I just quickly go through the Hallmark Lathe tool setter for those of you who are not familiar with it. So it has 2 main applications. One is an aid for setting and aligning your tools, so when you're mounting them, to get them set up for center height and angular and rotational alignment, you can rotate the tool setter until that little bubble is in the middle of the bubble vial, and that means that the anvil, that little block down there, is on the center line and parallel with the x-axis, and that really helps you for setting up different shaped tools, getting them in the correct position. And then after all your tools are set, you can set the tool offsets very quickly using, for example, rotating it depending on whether you got the tool on the front or the back, putting on the little LED and or beeper, and then just touching up, and you get the tool on Z0 and X0. I'll just go through that. I'll put it on a tripod and just go through that on a couple of tools. Okay, well, let's go through setting up this tool, this Trigon main turning tool. So we rotate the spindle until the bubble is in the middle of the bubble vial there. We advance the tool so we can set the X, put the little beeper or LED on, come back in until it makes contact, and at that point, I'm just doing it quickly to demonstrate it, but you can step it in. At that point the tool is on X0, and you just enter X0 into the tool touch facility, and then the same idea for the Z. So now we set Z0. So again, you can step it in if you want for the best accuracy, and enter Z0. So you just go through all the tools like that. According to the shape of the tool, it may be set up that way or set up that way, and it saves a great deal of time setting and mounting all of your tools. You might wonder, well, the Z's relative to the tool set are not the work. But what you're doing is setting all the tools relative to each other using the tool setter in the Z, and once they're all together as a family, then you can move the whole family of tool offsets to the position of your work, the end of the stock for example, and then you just change the work offset, and then the whole family of set tool lengths shifts to that new position. So that's the LTSE, the electronic tool setter. There's also an LTSM, a mechanical tool setter. Have a look on the Hallmark website for videos specifically about those two products if you're interested. Let's just go through setting up the boring bar, which is facing in the other direction. So we set the tool setter the other way, so the bubble is in the middle of that bubble vial, like that. Switch it on. If you don't like the beep, you can get a version that is only LED. Come forward until we reach contact, and at that point we enter X0 on the tool touch facility, and the same setup for the Z until we come in contact with the Z. Well, here I'm setting up that special grooving tool that I've just ground out of a piece of high-speed steel to cut the groove in the end of the body, and I'm using the tool setter to set up the tool height to check that the shim under the tool is the correct thickness. So I'm double checking there the tool height. Now we're going to set the tool offsets on that grooving tool, so we rotate the tool setter to the correct rotational alignment using the bubble in the bubble vial, move the tool forward in the Z, turn on the tool setter, come into contact, set X0, back off and set Z0, and then we've just like that set the X and Z tool offsets. So now I'm going to set this stop exactly in the right position. I'll just give you a quick look at it before I install it. So the main stop rod is a bit of 1/2 inch or 12mm bar running through the spindle, held down this end with a simple bush with a couple of soft grub screws holding it inside the spindle down that end. There's a location disc or bush halfway down the spindle which keeps it central, but that's a loose fit in there, just a bit of acetal or something. And then on the end is this key component which is a split bush. So I parted through almost 100%. So it's held in place by just a little sleeve of aluminium, and then there's 4 grub screws on the end, and that means that I can adjust the stop in a radial concentricity, and that's really important because it produces a concentric flat base to put your parts into, and it doesn't, so you're not relying on the chuck jaws to hold the parts perfectly concentric. A larger diameter part like that will not be held perfectly concentric by the chuck jaws. It needs to be set on the base as well as the chuck jaws, and so this allows me, with those little set screws in there, to dial it up perfectly concentric. I did a recent video called Fix Your Chuck if you're interested in getting the maximum accuracy out of a basic 3-jaw chuck, and I outlined that you machine a groove in the end of the jaws like that with carbide, fit a ring in there, and that splays the jaws outward in a bell mouth fashion, similar to how it clamps on the work, and then you internally grind it with a tool post grinder, and that way it gets the jaws both concentric and radial and axial direction, and that fixes 90% of your chuck accuracy issues. So have a look at that video if you're interested. Fix Your Chuck. Produced it a few months ago. So now I'm setting up the stop, but even if your chuck jaws are perfectly ground and accurate, it's virtually impossible to put a large diameter part in perfectly concentric, because the length to diameter ratio is not good, and you will end up by holding it slightly on an angle, and when you tighten the jaws up it'll pinch up slightly out of alignment. So it really needs to have a concentric base so that you have a complete concentric nest that your part goes into. So now I'm just adjusting those grub screws until I get the base concentric. So now the part sits concentric in that accurate little pocket, and we set the work offset. So we're putting in a tool, can be any tool, I'm going to use this tool, set that just touching on a part that I've already got, but I could machine it and measure it, and then we set our work offset, which is here. We only have to set the Z0, just push on that button or enter an amount, and that moves all of the Z tool offsets that you've set using the tool setter as a family into this new position. So they are all correct in this new position relative to that one tool that we've chosen to set it. And finally, don't forget to check your coolant is set correctly. It's especially important to check your coolant on something like a grooving tool, because you run a real risk of swath welding inside the groove without coolant. Finally, you can dial in the 3-jaw chuck perfectly concentric, putting a dial indicator on the top and adjusting it until it's perfectly concentric like that. I've talked about this in lots of other videos, but I really believe in having clearance on the chuck spigot, locating spigot, and just loosening those screws off until they're just nipped, and then tapping down, so you're using gravity, it'll go straight down, just to dial in those last couple of thou, and then tighten up those bolts from behind, and that way you've got an adjustable 3-jaw, and it's more accurate than a collet in fact. We're all ready to start production now. I've just inched through the first part and it seems fine. Obviously you have your maximum velocity slider right down there, and you're just tweaking it up and down a little bit to check that you haven't made a horrible mistake with your setup. There's about 100 things you could get wrong and have a crash, so you're just sort of inching through each of the tool changes and so on. And once one part's been proven, what I love about CNC is when you've got it running good on one part, it'll usually run fine for them all. But in a manual lathe, just to make one good part is only one good part. You've got to concentrate the whole time, and as you become more tired, you're much more likely to make, especially as you get more bored and tired, you're much more likely to make a mistake. That's a really interesting subject, CNC versus a manual lathe. I did a video on it a couple of years ago. If you're interested, look in my playlists under lathe. You'll see a video with the title something like CNC versus manual lathe. There's a lot of work in setting up a CNC lathe, because especially when you're putting all new tools in, it's a complete resetting of all the tool offsets, all the coolant, and you've really got to take your time or you can have a nasty crash. So in most cases a manual lathe is much quicker to set. So if you're only making one or two parts, a manual lathe is probably better for most shaped parts. But if you're making 10 or 20 or 100 parts, then it's worth spending the time setting up your CNC lathe, because it just repeats itself so quickly and so effortlessly. Well, this end's going very smoothly without any problems, very short cycle time. I'm really impressed with the Tormach Slant Pro 15L. You know, for what it is a budget made in China, low volume production lathe that can't have been fully developed. It's not fully resolved, and yet it is fundamentally quite well engineered, and it is quite accurate and quite repeatable and quite reliable for what it is. And it shows the talent of the original designer or designers. It's a sort of a triumph of design over workmanship in some ways, but it's held together very, very well. It's been very repeatable and accurate. You need to understand that it is a low cost, low volume, not fully resolved machine, but it's pretty good for what it is. So this production side's going really well. I'm getting through it really quickly now. You need to keep track and check each part to make sure that there's not any wear or dimensions drifting off spec, but they haven't been. It's just been staying on 100%. The only problem I occasionally have is if I don't fully clean out the little pocket or nest that the part goes into, and there's a little speck of dust or fluff on there, I get a tiny amount of variation in the length. But as long as I'm careful with cleanliness, then the parts come out 100%. So we're going to get through this side pretty quickly. Right, well, thanks for watching that episode or chapter. Hopefully you found something useful in there. And if you did, please like and subscribe. That helps with the YouTube algorithms, as you probably know, which brings it out there to more and more viewers. Please stay with me, and I will be editing and completing the next chapter or video and publishing it soon. Thanks for watching. Cheers. Throughout the course of this video series, I'll mention different videos that I've made on specific subjects, and to help you to find those, if you go to the Thread Express public homepage, you should see a page like this. Most of you will be familiar with this, but if you click on the playlists here, then you'll see all the different subjects split into categories. For example, you might be interested in spindle tapers, R8 versus TTS and so on, versus BT30, or whatever subject. Just go to the playlists, find the group of videos grinding related. You'll see there's a whole lot of videos on, for example, dressing your D-bit grinder diamond wheels. So just refer to it that way. Will be the quickest way to do it. There's several hundred videos there altogether.